I'm Reza Khorasaninejad. I'm CEO of LEADOPTIK. At LEADOPTIK, we designing image-guided biopsy needle to increase the accuracy of the lung biopsy. Lung cancer kills more than 3 next cancer combined. So it's a big issue, and despite the fact that there are a lot of technology development, there are 3 major steps in lung cancer biopsy. First step is a screening step. Normally what does it do is, they will go through the CT scan, find whether the patient have a nodule, and depending on that nodule, go to the second step, which is finding the nodule. And that's where the battle of robot is happening. Monarch or Johnson & Johnson, I know Intuitive built the entire hardware and software system to navigate through the maze of the lung and get close to the nodule. The last step is to taking the tissue. No matter people are using $1 million robot or a manual bronchoscope, they still rely on one old technology and one new technology, but very expensive. The old technology is ultrasound. 70% of the lung nodule in the lung periphery, what happens is they need to use a small bronchoscope. A small bronchoscope has a small working channel. It just only allows for ultrasound to go in. After they find the nodule, they need to take ultrasound out to make the room for the needle. So this exchange between devices increases the error, and error can be up to 44%. 4 out of 10 people were told you don't have a cancer, and they come back in 6 months in a year with much, much larger nodules. The other technology that mostly robotic companies use is cone beam CT. That's very expensive and also put everybody at radiation. Our technology called LEA system, basically last inch assessment. What we do is we rely on any other technology to get close to the nodule, and we finish the last step. So we have an imaging console and a disposable device, and we will place the imaging console in a hospital based on the placement agreement that we have, but the disposable device, like any other needle, which can be used one time for the patient. Why it hasn't done before is it's really hard to miniaturize imaging system and integrate it with the needle. So we leveraging in a cutting-edge technology called metasurfaces. Basically, in a nutshell, we combine advanced optical design and nanofabrication. We can shrink optics thousands of times. That allow and enable integration with the needle. There is another part that we use this technology. Normally, when you use optics, your resolution is great, but what happens, your distance from your optics and the tissue need to be in a specific distance. I'm sure everybody uses a microscope. When you use a microscope, if there is any vibration in your system, image go blurry. That means your depth of focus is really small. We solve this problem by, again, metasurface technology that allow us to do imaging anywhere in the lung. So normally, lung airway is from 2 centimeters from an adult to sub-millimeter size. In my newest slide, I have put the 2 centimeter diameter. Basically, this is a cross-section of lung airway. What we do is our device would be at the center of it, and we can image all the way when the airways become smaller. Because we have a higher resolution imaging, is 50x better than ultrasound, we can basically differentiate between healthy tissue and tumor. Here in the top 2 images done by us on a human cadaver, a patient have a lung cancer. Image on the right is from healthy tissue. As we expected, it network-like a structure in a very good agreement with the pathology image and histological image that we have from a third party. The part of the tissue that has a tumor and cancer become homogeneous. And you can see there is at least for me, it's easy to differentiate between an homogeneous medium and a network-like structure. And there has been a huge study that the specificity and sensitivity of this depth imaging technology is above 95% for detecting the cancer. So histology, normally how they do is they cut the tissue, they send it to the lab, slice it, put it on a slide, put it on the microscope. What we do is everything is in vivo while they're doing the biopsy. In a long term, what we do is we want to unify the workflow with one device. For the last inch delivery, as of today, when the robot or manual system gets close to the nodule, they rely on several technologies to make sure they can collect the tissue. After they collecting the tissue, either they bring a pathologist in the room or send it to the pathology lab to see. What we want to do is we want to unify in the last 3 steps. Are we in the right place? Are we collecting correct tissue? Is it cancerous or not? In the US alone, there are 659,000 cases. So that will put our beachhead market around $800 million. And we have come in a long way. So we raised our first check on a slide deck in 2021. Now we already freeze our design. We are in a sprint to submit our 510K by August 2024 of this year. And we build our clean room. We can do our device in our own clean room, prepare for verification and validation. We are in contact with a lot of strategic partners to either work with them for co-development or just use their sales channel for selling our disposable device. So we're raising our Series A to basically commercialize this technology and do our pivotal study after FDA. We are 510K class 2. We don't need human study. So the team is, my co-founder has a decade of experience in medical imaging. Alex G, I know him from Harvard. He was our advisor for 1.5 years, and he is now his chief medical officer. I have Nick here as well. He has a fantastic record of sale and marketing in big and a small company. And we have a really strong engineering team. 2 of our mechanical engineers have 8 exit as an early stage medical device employee, and they just completely change our device outlook. We have a great advisor. One of our advisors is basically the founding father of this imaging technology. And we have a lot of great IP interventional pulmonologists in our team. We are supported by a great institutional investor and angel investor. And thank you so much for your attention.